Hello everyone, this is Mrs. Snook with section 4.8, Applications and Models of Trig Functions. This is our last section in chapter 4, and so after this we're going to review and then have a test. Our objectives are to solve real-life problems with right triangles, to solve real-life problems involving directional bearings, that's super cool, and to solve real-life problems involving harmonic motion. Also super cool. First one is involving a right triangle. And this one is just like what you're used to from geometry and algebra 2 trig. I'm going to solve for all the unknown sides and angles in this triangle. So the first thing I'm going to do is I'm going to get angle B because that's nice and easy. Angle B is going to be a 180 minus our 34.2 plus 90 because all three angles in a triangle add up to 180. So you just add up the two that you know and subtract them from 180. And when I do that, I got 55.8 degrees. And now all that's left is to get A and C. I'm going to go for A first. And I'm going to use a trig function. I know the tangent of 34.2 is going to equal A over 19.4. And I chose tangent because A is opposite and B is adjacent. So then I just multiply both sides by 19.4. So A is going to equal 19.4 times the tangent of 34.2. And that equals I got 13.2. And I don't have any units, so I'm just going to leave it without units. And then to get C, you have several options. You can do Pythagorean theorem if you want. You can do any number of trig functions. What I think I'm going to do is I'm going to use 34.2 degrees, and I'm going to use the 19.4. And the reason is both of those are given numbers. So if I've made a mistake in getting little a or capital B, that mistake will not follow me through the problem if I do it this way. So I'm going to say the cosine of 34.2 equals 19.4 over C. Remember, C is your hypotenuse, so cosine is the trig function to select. And then when I solve for C, I get 19.4 over cosine of 34.2. And just punch that up in your calculator. And I got 23.5. So that's C. All right, so now we've had a brief review of solving a right triangle. We're going to look at a real-life situation. We have a point 200 feet from the base of a building, and the angle of elevation from that point to the top of a snowstack is, to the bottom of the snowstack is 35 degrees, and the angle of elevation to the top of that snowstack is 53 degrees. So when I look at my picture, here's my 200. A is the height of the building. S is the height of the smokestack. And if I use the 35 degree angle of elevation, I can get A. If I use the 53-degree elevation, that will give me S plus A. So I'm going to end up having to get both of those numbers, and then to get S, I need to subtract. So first let's get A. And I know tangent of 35 is going to equal A over 200. Because remember, A is your opposite and 200 is adjacent in this triangle. So therefore, A is going to equal 200 times the tangent of 35. And that equals, I get 140.04 feet. Now I'm going to get S plus A. So tangent of 53 equals S plus A over 200. So then S plus A is going to equal 200 times the tangent of 53. Is 265.4 feet. So that's giving me the height from the ground all the way up to the top of that smokestack. So if all I want is the height of the smokestack, I'm going to subtract them. So S is going to be 265.4 feet minus 140.04 feet. And I get 125.4 feet. Okay. All right, the next one is with trigonometry and bearings. So we're talking about navigation here. And in this example, it's the navigation of a ship. The ship leaves port at noon and heads due west at 20 knots, which means 20 nautical miles per hour. At 2 p.m., that's 2 hours later, the ship changes course to north 54 degrees west. So look at this figure here. This line I'm sketching, and that's a north-south line. So north 54 west means you go to the north, and then we're going to go 54 degrees towards the west, and that's going to be our bearing. And what we're asked for is the ship's bearing and the distance from the port at 3 p.m. So the first thing I need to do is figure out little b, little c, and little d. Once I have those, like little c gives me my distance. And then once I have little b and little d, I can easily figure out this angle in here, theta. And that's going to give me the answer for my distance and my bearing. So first, let's get little b and little d. So right in here I have 54 degrees. I know this is a right angle. So therefore, my angle in here is going to be 90 minus 54. So inside this little triangle over here that I'm highlighting, we have a 36-degree angle. And we know the hypotenuse is 20 nautical miles. So if I use, let's do b. So if I'm going to use sine of 36 equals b over 20 nautical miles. So then all I have to do is multiply to get b. So b is going to be 20 nautical miles times the sine of 36. B equals, I got 11.8 nautical miles. And I just want to mention, as you're doing a problem like this, it's very helpful to have a picture and very helpful to keep marking and labeling your picture. All right, now let's get little d. I'm going to use the same triangle, but this time d is on the adjacent side, so I'm going to use cosine. So cosine of 36 equals d over 20. So d is 20 nautical miles times the cosine of 36. 20 times cosine 36. Punch that in your calculator. And I got 16.2 nautical miles. So that means that this whole distance from the port all the way to the end there is going to be your 40 nautical miles plus 16.2 nautical miles. So this is a 56.2 nautical miles. So now I have enough information to calculate theta. Tangent of theta is 11.8 over 56.2. Now to get theta, I do inverse tangent. So theta is going to be the inverse tangent of 11.8 over 56.2. Punch that into your calculator. And I got, oops. Divided by 56.2. I got 11.9 degrees. Now take a look at our picture. We were heading due west. So this is going to be a west, 11.9 degrees. And then you turn a little bit north from there. So our bearing is west, 11.9 degrees north. So that's that part of the answer. Now let's just get C. Lots of ways to do this. I'm just going to go ahead and use Pythagorean's theorem this time. So C is going to be the square root of 11.8 squared plus 56.2 squared. And I got 57.4. Remember, our units are nautical miles. All right, the next one we're going to do is with harmonic motion. And harmonic motion just means that your device is moving back and forth. And it says here, a point that moves across a coordinate line is said to be in simple harmonic motion when its distance, d, from the origin is given by either d equals a sine omega t, this little w is pronounced omega, or d equals cosine omega t. Now we're only going to use sine. Don't worry about cosine. And this is a change of notation for us. We're used to saying that y equals a sine of b x minus c plus d. But in harmonic motion and also in electrical engineering, we change our notation a little bit. And it becomes d equals little a. So instead of our capital A, we're doing little a. Sine, that stayed the same. And this time, instead of b, we're going to use omega. And we're not doing a distance, we're doing over time. So that's why we're using t. So all we have to do is find a and find omega, and we can write our equation. So here we have an example of a spring, and there's a ball on the end of the spring. And kind of imagine this ball moving up and down with the spring. It starts off at 0 centimeters, so this would be no displacement at all at 0 centimeters. And if it goes down, its maximum negative displacement would be 10, and going up, its maximum positive displacement is a positive 10. So therefore, remember, we measure that amplitude from the midline. Our midline is at 0 centimeters. So we can think of it as going up to 10, back to midline, down to -10, and back up to midline. So A here is going to be 10. The only other thing we need to figure out is omega. And we are told that the period of this motion is 4 seconds. So it takes 4 seconds, so starting here, ending at 4 seconds, to do one complete cycle through. And just like before when we said period equals 2 pi over b, we're going to use omega now. So period is 2 pi over omega. So 4 is going to equal 2 pi over omega. And just solve for omega, you get pi over 2. So we have our A is 10. We have omega is pi over 2. We're ready to write our equation. So y equals 10 sine of pi over 2t. And then the second thing it says is, what is the frequency of this motion? Well, omega is the frequency. So the answer for the second part is, what's the frequency of the motion? Right here. And that is it for today. Thank you for watching and have a great day.